So what if AI agents could access your databases, and in particular databases that have been locked up inside your backup repositories? What if you could reuse that data without actually having to send it all the way back to production in order to gain insights? What answers could you ask of your data, and what would the insights would that give you? And so I think we're nearly there. The technology has been around for a very long time. And the answer actually lies in something that Veeam Data Platform has had around for a very long time, well before the AI boom. And it actually starts with this instant database recovery technology. Started back a number of years ago, and in essence what it allows you to do is any protected MS SQL or Postgres database that's held within a backup repository can be instantly published out of those backup repositories without having to transit all that data to a SQL cluster, and actually publishes that database ready for interrogation. So now we can use any database tools that we like to start interrogating the database using that database. And of course it was designed for DR scenarios, failing things over and recovering and just generally making yourself more resilient. But what if we could use that same process to connect ourselves to in order to connect some agents? And so this is largely what the process would look like. We publish that database through like on step one, and then the little purple brain here with AI in it, this is our AI agent system. So let's take a look at what's possible. So what we have here is a web interface that's already connected to an instantly published database. That database is spun up out of the backups. It's connected into, in our case, an MS SQL database here. And I can now connect this API, these agents, to the SQL database and start asking natural language queries. So let's start with something nice and simple. Now remember, I might not know what's in this database. I might not know how to write SQL, and that's the intention. You can just describe what you want in natural language, and the agents will orchestrate everything for us. So let's ask something really simple like, what does the database contain? So what's going to happen here is the agent's actually not only going to show us our thought process, which you'll see is a pretty common thread, but it's going to interpret that query. What does the database contain? And so it's given us back a list of tables. So now we loosely know what we're looking at. We've got actor, we've got city, country, we've got customers, films. There's a bunch of tables in here. And if we take a quick look at the agent work plan, you can actually see that it's leveraged a few steps to get there. The planning agent just determined that the plan should be to list all tables. And so we're inferencing, in this case, GPT-4o Mini as the model, but I've also tested this on the open source or open weight versions of this, such as OpenAI's GPT-OSS running on my own hardware here, and it works just as great. So you can see then it passes it through several steps, including passing it across to a SQL writer. So it passes that list all tables plan to a SQL writer, and it knows what type of database it's talking to. So it's going to get that syntax right, and it's written that query, and then a SQL execution agent actually goes off and handles the running of that query and returns us the results. So kind of interesting, but not kind of where we want to get to. So now we can kind of ask perhaps something more advanced. Just copy my query down here. So what if we wanted to ask the agent, show me the payment total collected by each staff member, show me the total and the name of the person. So very much a natural language query that we are interpreting here. And again, that planning agent's going to run through everything it needs to plan. You can see that's returned our results now, John Stevens, Mike, and it's got the total here. If we look through that agent plan here, there's actually a couple of things going on. Obviously, the planning agent here is a little bit more detailed, but you can also see that there's a table correction agent coming in. And because I said payments, there's no table that exists that's payments. And I didn't necessarily need to know that. There must have been a SQL error, it introspected that, and then what's happened is it's corrected it to payment because it's able to understand the schema of this database. And then the SQL writing agent, you can see, it's actually done a relatively good job here. So, it's combined a couple of fields for us, and it's done a join across onto the payment table and things and returned that. And of course, one thing that it always does here at the bottom is this review agent. This is really critical. It takes the output of all of these agent steps and reviews that with our original query and compares the result versus the query, and then it does a kind of interpretation of whether or not that actually answered my question or not. And if it doesn't, it actually loops back around and goes through the steps again. So that's pretty great. So the other thing it can do is obviously, we might want to say, number of movies we store for each rating. So again, that's a pretty broad prompt, but the AI agent will take that and interpret that and actually return us back the results. So I'll just copy this other prompt here while that's running. So you can see now we've got a list of ratings, the movie ratings there, how many movies we have in our database that match those ratings. Work plan looks very similar. It's done a group by, an aggregate query. It did a correction here from movies to film because that was the name of the table. So again, really interpreting exactly what we're typing in perfectly. So what if we wanted to now visualize some of this data? So what we can do now here is ask for a bar graph of the total number of movies in each rating category. So a very similar query, our text-based query as before. But there's another agent here and another step that it can include as part of its inferencing. Is to work out whether or not it needs to generate a graph for us. This is just going to be a very basic image generation, but this actually could return anything that we liked and actually render a more rich graph that's kind of interactive inside this UI. But for demo purposes, you can see this has actually been generated kind of server side on our API side, and then we're able to inject that. And so if we expand the agent work plan out here, the steps look very similar, but you can see the visualization planning agent then took over and actually interpreted those SQL results that the SQL executor returned, passed it through to a visualization planning agent that knows how to work with that information and actually generate a bar graph. So what if we also then we can determine what type of graph? We obviously didn't specify that on the last query, so it just gave us a bar chart. But what if we wanted a pie graph? So we can just ask that again in plain language. Similar query, doesn't need to be exactly the same. And in a second we should see back a pie graph. So one thing we can also do is ask say about our customers. So what information do we store about the customer? This should be another one where we start doing table correction agents and things in here. So we'll let that run back, but it should actually give us sort of some detailed information back about the customer. So wait for this to return, and then we'll see where we land. I'm just going to copy another thing here. So you can see this has actually given us the actual schema back, which is pretty neat. So now I know these are the tables. I can actually start asking what columns exist in this thing. So I can get more specific, maybe with what type of information I want returned about a customer. Maybe I want the first name and the last name and their address, or now I know there's an address ID, so there's probably an address table. So I could just start describing, show me all customers, their first name, their last name, and where they live, and it would return that. So the other thing we can do is redact information. So I've got a biography table. I'll just show you two results here. So I'm just going to put a simple query in like show me two biographies, and that'll return back a limit query and just show us the first two that it sort of selects there. So that'll come back here and we'll see those table results. But you'll notice there's a little eyeball down here. So I'll get this ready here so we can run this again. So you can see, hello, my name is, it's got some other things like phone numbers, email addresses in it. So what I'm going to do now is show me two biographies, but I'm going to select this little eye icon and we'll run that query again. So what happens now is if this mode is enabled, before the reviewer agent sends it back, it'll actually review any of the response that we need to be returned to us, but it actually passes it through a separate service that runs that's a redaction agent. So first it looks at all the text, it runs it through a PII detection service, and then actually returns it back redacted and replaces everything out. So now you can see, hello, my name is person, date, time, there was that phone number there, and there was that email address. So you can see that's pretty neat. All we've done is really just talked to our database with natural language, we've generated graphs with it, we've redacted information, we've done joins across different tables. I haven't needed to know how to write SQL, but I could gain really good insights just by describing to this system what I like. So roughly, for those of you who are still watching, this is kind of how it all works. There's a number of agents. These are out on the left-hand side here. So a planning agent is a SQL writing agent. That we've got a visualization planner. You saw how that was used. We've got the redaction agent down the bottom here, the reviewing agent. And you'll notice these kind of red lines. The agent system actually has a number of retries that it can do, but it feeds the error from each step back to review. So if it got the SQL wrong, maybe we'll get a SQL error back as an example. And so we pass that back to the writing agent and say, hey, you wrote this SQL query before, but this was the error. Please go and correct it. And then more times than not, it gets it fine. And so even though it might retry, it'll correct itself. And sometimes it just runs to failure. That's just the nature of it. But most of the time it gets it correct. And so largely that's how everything kind of stitches together. So hopefully that gives you a really good overview of how you could use something like this combined with Veeam Data Platform's instant database recovery to get access to structured data sets that are not only maybe long forgotten, out of those backup archives, but you could also start reusing a lot of that backup infrastructure to really start harnessing any form of AI system around it. Even if you didn't want to touch necessarily production, you could use your backup systems for that.